Hello, Elena. Thank you very much. Hello, everybody. First and foremost, thanks a lot for inviting me and give the opportunity here. So thanks a lot to Kato and everyone else behind the conference. Glad to be here. You already introduced me. Before jumping in, and I'm conscious of the relatively limited time here, before I introducing the use case itself, I just wanted to very briefly introduce CKDelta, who we are, what we do. Not everybody could be, familiar with our brand, but I'm sure that a lot of people are more familiar with our group company brand. So we are a CK Hutchinson Holdings data innovation company. CK Hutchinson Holdings is a global conglomerate that works in a number of different verticals. Those verticals include telecommunication networks. So I'm pretty sure everybody in this country and many other countries are familiar with the Three brand. It's a group that includes a world's leading port network. In this country, again, many of you are familiar with Felixstowe ports and many others across the country and abroad as well. That is part of the ports vertical of the group. We have a retail vertical as well. The name is A.S. Watson, but that includes a lot of different brands. And you might have definitely seen things such as Superdrugs or Marionau in UK, as well as abroad in Europe and globally. And last but not least, and actually the most relevant probably for what we're going to talk about today, is the infrastructure side of the business, which includes a number of network operators and energy and power companies globally in about 32 countries, including, management of water and wastewater services, as well as power generation, electrical and gas distribution networks, and so on. So as CKDelta, as data innovation company for the group, what we do is we sit at the intersection in between what is the domain knowledge of all of these different verticals and all of these different businesses, but also we look at all of the data that are available to us through our business and through externally available data sets as well as the technology side. So we literally sit at the intersection of the three, and our vision is to use that intersection and use that visibility and that availability of assets and resources to produce value for the group and for the customers of the group as well. Specifically, I lead the utility side of things. So what I'm going to talk to you about today is about the energy system and how we are adding value to that system, leveraging data science. So many of you might and should be familiar with the big shift that is happening in the energy system. This is a shift that, to exemplify it, is happening really on two sides of the coin. On the left side, you can see what I call really the technology push drivers. So the fact that there is an uptake in technologies such as electric vehicles, distributed energy resources, battery storage, photovoltaic panels, and so on, is the fact that technology is advancing in a way that is making more and more likely for people and organization and infrastructure managers to adopt those technologies. And on the right side, you also have a demand pool aspect to it, which is where all of the behaviors of customers, people, and organization that revolve around the energy systems are driving a change, a transformational change. A very simple example of that is, the net zero focus we just recently had in the COP26 conference, but also the COVID. We're all familiar now with the changes in our own behavior, in the way, for example, that we move around, in the way that we leave our houses and the offices over the last 2 years has massively changed. And all of that is tied together by the fact that there is an ever-increasing digitalization of all of these services and all of this infrastructure. And that digitalization generates and creates data. Data can then be applied, reapplied, and leveraged to generate even more insight. And this is really what the core of our use case today is. We are working with one of our Hutch companies and distribution network operator for London, south and east of England, UK Power Networks. We've been working with them now for a while to understand how we can leverage all of this new data that is being created by the evolving energy system in order to generate value for them as an organization, but most importantly for their customers that are starting to be, I don't want to say confused, but obviously there is a lot more variability in the type of services that they can receive and they receive on a daily basis by these energy companies. So a customer that is, for example, going to buy a new electric vehicles, they would want to have the availability of the charging infrastructure available for it so that they can reduce their range anxiety, for example. That's just one of the many examples. Electrification of heating is another one as well. Therefore, what we are doing with them is like we're developing and we've developed an alternative way of leveraging traditional data and cross-referencing those traditional data with external data sources and machine learning technologies to fundamentally create a simulation environment of how power is flowing through the networks at low voltage level. What low voltage means, for who is not used to that type of thing, is fundamentally the most granular level that you can get on a power networks, and it looks at how the energy flows around cables and substations and assets which are very close to the end customer, which might be a residential premise or it might be a commercial or an industrial premise as well. So here I think is the core of what we're doing, which is somehow puts the focus on what we call located intelligence as opposed to location intelligence. And when I say as opposed, I don't mean that they are alternative to each other. Most of the time, they're actually very much complementary. But what we always think about is that whereas a location intelligence puts an accent of the location itself, so identifying a location and then trying to somehow elicit as much knowledge as possible about that location. And again, I know I'm simplifying a little here, but bear with me. What we try instead to put the accent on using the term located intelligence is the fact that we tend to look at this problem with a holistic view first. So understand what is the full supply chain around that energy service and how it's changing, and then starting bringing in data, knowledge of the domain, technology to start building up an overall holistic solution for that problem, and then located geographically in all of the places that it might be most useful to be applied to. It's very similar, slightly different approach, but I think it's very important, especially if we talk about overall energy system, which is very much a complex and interconnected challenge. And UK Power Networks is at the heart of it as a distribution network operator. So just to go a little bit more in detail there, what that means in the specific example is that in order to facilitate a transition to an energy system that can support and enable the adoption of all of those technology that I've mentioned before, there is a fundamental need to have visibility of what is happening on all of these different sides. So the example would be a network, distribution network in this case, where comparatively, if you think about 10 years ago, the uptake of things such as renewable energies that are being connected up to the network, or things such as battery storage being connected there, as well as electric vehicles and charging infrastructure, electrification of transport, photovoltaic panels, all of that is creating uncertainty onto the network. So the current visibility that most of network operators have at LV level is limited, and the fact that it's limited is making more difficult to incentivize the adoption of those technology and improve and make sure that the services are properly offered and at the level of service that is required by the customers. So what we're doing is we're building a virtual sensing network using predictive modeling that leverages a number of data sources, including both the historical and traditional data around those assets, but as well leveraging a number of other data sets, which includes demographics and microdemographics, mobility, and location, obviously everything in its most aggregated and anonymized form, as well as open data sets such as like building stock, energy ratings, weather, and many others, in order to streamline a view of that dynamics and the demand of that network, and help all of the network supply chain and the energy supply chain to be able to put in practice the actions that are required to meet that demand. So I know, and I'm aware of time as well, I know that it's a very complex topic. We could be here talking about this for a very long time. At least I could, definitely, for hours. But I wanted also to leave some more space before the end of the session for some questions and hopefully good answers from me as well.
Excellent. Thank you, Simone. It's really cool to see how the small consumer habits, seemingly small, as well as some of the large changing consumer habits that have been pushed by COVID, kind of the larger impacts of some of those things that you might not notice, because every day you're like, oh, I'm just changing small things, but then seeing the larger impacts for like network demand and things like that is really interesting.
Yeah, it is, and actually, you remind me of an example that whoever is been in the industry for a bit longer. This is a bit an old-fashioned one, but it makes the point. I think is that in this country there's always been a peak in the demand whenever people would turn kettles on at the end of the break for EastEnders, which is a very small micro behavior which collectively has got a massive impact onto the systems. And well, at the time, it was the uncertainty around what those micro behaviors could be and how they could change was much lower than what we've got now, because today we've got many more variables. Hence, what you're saying is absolutely correct. There is even more a focus on trying to get it right and make sure that we can satisfy customer expectations while driving the whole system towards sustainability goals and environmental sustainability goals as well.
Exactly. And I know you did want to leave time for a couple of questions. So we have one in the chat here. Which machine learning algorithm did you use for the predictive modeling?
That's a very good question. To be fair, we haven't used just one algorithm. It's a suite of different methodologies, and as you can imagine, the amount and the volume of data that it needs to be ingested requires models even just for data preparation, as well as then for the actually predictive element of it. But there are different models that are utilized that span from a number of those, including decision trees all the way down to clustering and classification methodologies. So it's very wide array of algorithms there.
Gotcha. That makes sense. Always more complex of an answer than you might think. So appreciate that one. And then, so how can network planners go beyond census data and other traditional data sets, such as some of the data you've discussed, to understand consumer propensity to buy something like an electric vehicle?
It's a very good question. Reason why it's a very good question is that actually the propensity to buy an electric vehicle can be, so to speak, an output variable, which is what the question is about, right? So how do we use other input data to get better propensity? But actually, in itself, it can be also an input variable, because you can use propensity to buy to actually infer the overall uptake of electric vehicles and thus the requirement for example, network reinforcement to allow more capacity for charging infrastructure. So again, the answer is not as simple as it might seem. But there are a number of both proprietary and open source data sets that, if put together, can be used to start validating some of the assumptions around uptake of electric vehicles and increased new registration of new electric vehicles as well. The core really goes back to the ability of understanding what is the specific question that one is asking, finding out what are the main top drivers that might be driving those dynamics to change over time, figure out whether they're measured somewhere, and whether there are data available there, and then put them all together to start getting an incremental answer to those questions.
Absolutely. I like the way you kind of turned that question around. You said, yes, like consumer propensity to buy can be an output, but let's think about it as an input as well. So it's interesting.
Absolutely.
But I think that's all the time we have. Again, really appreciate your presentation. For anyone